so much for joining us today. Really appreciate it. I know the world is a crazy place right now, and the fact that you guys would take the time to do this, means a lot to us. So good morning if you're in the US, good afternoon if you're in Europe like I am. And if you are dialing in from Asia, I have a lot of respect for you and we really appreciate you getting out of bed. So thank you very much. My name is Kate Smaje. I'm a senior partner based out of London, and I'm the global leader of McKinsey Digital. I'm really excited today that we're going to be spending real time talking about security as code. It is just such an important topic for us, and I think that's really evidenced by just how many people have signed up and turned up this afternoon to talk about this topic. And we're going to be joined by the absolutely fantastic Phil Venables from Google Cloud, as well as a few others on this call. So it should be really exciting. For those of you that don't know McKinsey Digital, and I do see many friends on the line, but for those of you that don't, we are, everything that you probably know and hopefully love about McKinsey. But then we really spend time partnering from C-suite right the way down to frontline, helping our clients to transform how they work with technology, to integrate new technologies where they matter most, and really to embed that change and sustain that change through capability building, as I say, right the way down to the front line. And often these are capabilities that people don't necessarily associate with McKinsey. So we're really delighted today to bring and share a little bit of that with you. In addition, if you do get a chance at some point today, hopefully not while we're on the line, please do check out cloud.mckinsey.com. It'll give you a bit of a sense of some of the work that we do in this space and some of the impact that we are having and the partnerships that we're very proud of. We partner in an ecosystem of more than 900 different partners to really bring the best of these capabilities to our clients, whether that is AWS, whether it is GCP, SAP, Microsoft, and many others. And you'll see all of that, as I say, at cloud.mckinsey.com. As I said at the start, these themes are so important that we're going to talk about today. And I had the real pleasure earlier this week of, I think I can say this, Phil, of geeking out with Phil in London over a cup of tea. And we had a ton of fun. So I hope you guys are going to have a ton of fun with this today as well. But let me share maybe a little bit of brief background on the two folks that I'm going to introduce you to in a second. Firstly, Rich Isenberg. Rich Isenberg's a partner out of our Atlanta office. He's going to be facilitating the discussion with Phil today, probably to stop me from geeking out once again. Rich has been a wonderful colleague of ours for more than 20 years, had a 20-year career as really leading executive teams who are focused on cyber and bringing experience across financial services and also building up world-class offensive and defensive cyber capabilities. He was the CISO at SunTrust for many years and also led cloud security at Capital One. So really brings a wealth of knowledge. Phil Venables then is the CISO, for those that don't know, and the Vice President of Google Cloud, where he leads the risk, security, compliance, and privacy teams all brought together. And as we were talking through earlier this week, I think that's just a wonderful representation of all of these different capabilities that need to come together in this space. He also oversees a team of security industry experts, leaders in the Google Cybersecurity Action Team, who partner with their customers to really think about how do you design secure digital transformations. Before joining Google Cloud, Phil was a partner at Goldman Sachs for many years, where he held a variety of different roles. Obviously, initially as their first CISO as well. Outside of Google, he is a member of the US President's Council of Advisors on Science and Technology, and also serves on the boards of the NYU Tandon School of Engineering and the NYU Stern Business School Volatility and Risk Institute. So two really wonderful individuals, both on this topic, but also as wonderful humans as well. But enough of the CV sparring. Let me maybe hand over to Rich to get us started on the questions. Thank you, Rich.
Great. Thanks, Kate. Thanks for the great intro. As Kate mentioned, Rich Isenberg, I'm a partner with McKinsey in our cybersecurity and cloud practices based in Atlanta, Georgia. We're thrilled you've all joined us today. We see the more participants are still joining. We have over 330 on the line today, and we hope this becomes a very interactive session. Before we dig in and start, I really want to encourage everybody to share your questions in the chat function of Zoom. The chat box, just post your questions or topics in the chat function. We'll be able to see all that, and we'll take those into the conversation as the opportunity arises. We really want this to be interactive. We want you all engaged, and the more questions, the more engagement, the better. If you experience any technical difficulties or are having trouble hearing or need to find different numbers to call in on, please just request that assistance in the chat function as well. So let's go ahead and get started. Phil, thanks for being here, first of all. There's been a lot of talk and writing in the past few years about what's been known as the shared responsibility model. The internet is littered with color charts and graphics about where a customer's responsibility is for security and where a cloud provider's responsibility is in security. As there's been a crescendo of cloud migration, especially in heavily regulated industries, the regulators have made it clear that they really don't believe that risk can be fully transferred to a third party you're doing business with, that the customers really own all the risks and have to accept management of it. You've been writing a lot lately about what you're calling the shared fate model and how that's an evolution from that shared responsibility model. I was hoping you could talk a little bit about that and tell us how the providers are starting to evolve their thinking there.
Yeah, sure. So again, I think a lot of the people kind of connecting in today will have a very good understanding of the shared responsibility model. And, but just to kind of recap, this is where the cloud provider, although you could apply the shared responsibility model to many other relationships, but in the context of cloud, it's this notion that the cloud provider owns the security of the underlying infrastructure or service, depending where you kind of draw the line. And the customer is responsible for the security configuration and the appropriate configuration of their environment they're running in the cloud. And again, to be clear, this is strictly and contractually correct. That has to be that delineation. But ultimately, I think a lot of us were historically finding this dissatisfying, and you see a kind of a number of incidents in the industry where customers have misconfigured something that's led to a breach, and the cloud provider has been very quick to point out almost like immediately that it wasn't their fault, and this kind of seems dissatisfying, and it's not. We don't think it's really in the spirit of customer partnership. And so when we kind of were thinking through this a while ago, we thought, the real model really is one of shared fate, which is the cloud provider and the customer really in it together, and to make sure that the customer is as protected as much as they can be. And so when we kind of thought about shared fate, it's as much of a philosophy as anything else about how do we as a cloud provider reach across that line of shared responsibility and really partner with the customer on making sure that they're secure. And this includes a lot of practical things like really looking at our secure defaults in how we ship products. We have got a lot of very, very good secure defaults, like, for example, encryption being on by default, and that's not something that customers have to enable. But there's many, many other things. And to be totally honest, I don't think any of the cloud providers have made the perfect choices on secure defaults. We're going through a review, as we constantly do, looking at, are there any ways we can kind of change things to get to an environment where, as much as possible, we're shipping with what you might say is full safeties on, and then the customers can ratchet those controls down if they want for their own risk appetite. It also includes things like shipping security blueprints around what's our opinionated view of how the products and arrangements of products should be configured. And again, this kind of comes into our theme around security as code, and that's not just shipping kind of nice pictures of architectures and checklists. It's actually shipping code that can stand up a secured landing zone or blueprint of an environment. And then it also includes making sure that there's policy consistency between products. So if you're setting a policy setting at one level, it should reflect down the stack automatically without customers having to go make multiple changes. And then finally, in the ultimate expression of shared fate, it's also offering discounted cybersecurity risk insurance. So we partnered with Munich Re and Allianz, enabling customers to get discounted cybersecurity insurance. And we can do that because we let the insurance companies review and inspect our environment. And then we also provide product that lets customers send their configuration code to the insurance companies, so the insurance companies actually get real insight into how things are configured, such that that enables their underwriting process. So kind of net, this is a transition from shared responsibility to shared fate. Really enables a lot closer partnership with customers to really drive that degree of security in their environment, and it becomes a true partnership.
Great, thanks, Phil. Good. I think it's moving in the right direction. And one of the key things you said there was the ability to provide blueprints. You know, as we see a lot of cloud implementations and cloud deployments, we're finding there's this decision tree that has to happen between I have a legacy set of tools and security stack, and now I'm thinking about which one of those move to cloud, which one of those can still apply, and where do I adopt the native offering from the cloud service provider? How are you with your blueprints thinking through with the companies that have these hybrid, large-scale legacy environments that are going to live in perpetuity for some point in time, as far as helping with those decisions? Where do they go with a cloud native tooling blueprint versus where are they bringing their own stack with them, and how do your blueprints accommodate for that?
Yeah, I mean, they're actually quite wide ranging now. I mean, so when we started off with blueprints, they were very, very specific about what's the blueprint to stand up a cloud project, what's the blueprint to stand up a data platform in the cloud. They're very, very specific. But increasingly, as we've deployed more product in multi-cloud ways, and also as we partner with customers, as you described, that they're not just creating natively in the cloud, they're migrating to the cloud, or they're building or migrating to the cloud that connect back to on-premise systems, or even in the cases now, we actually have the ability to kind of connect to run products and services to help customers in multiple clouds. And so our blueprints have evolved to take that into account. And the blueprints not just encode that kind of configuration code about how the environments are stood up, but they also give a lot of kind of guidance around how to in effect kind of apply segmentation to some of the historical environments. What are the techniques we've observed that are the best practices for effectively re-architecting for the cloud, but also for certain things that may not be able to be re-architected for the cloud? How do you effectively wrap that in a way that's protected, such that you can still get the security benefits of the cloud without necessarily having to refactor absolutely everything? And we continue to make the blueprints more diverse as a result of that, and generally kind of more recognizing that we kind of meet customers where they are, as opposed to just expecting absolutely everything has to be re-architected for the cloud.
Great. And there's an interesting comment from an audience member that I'm going to read out loud. So the relationship between a customer and a CSP is much like that of one between spouses, that both need to reach out, and that's the only way to keep sanity, security, and commerce at large. I think we all support that. Just comments on how you've seen, Phil, the relationship evolve. Maybe the starting points where I think the cloud providers very much came from a perspective of we are a software and services company and we're selling software and services, to where it's evolved now, some of with the shared fate model. But what's the interactions you're seeing in the customers that are coming on board now? What guidance are they seeking from you, and what's the constant feedback and loop that they're engaging with?
Yeah, I mean, look, it's an interesting analogy about the spouses. I'd probably say it's more like an extended family, because it's typically we're often kind of working with customers that are running on-premise, multiple clouds. They've still got some enterprise software vendors that we partner with on hosting in the cloud to continue to provide customers support in the cloud from what they historically had on premise. And we've gotten very good at kind of helping people manage all of those relationships. But I think really the the customers kind of want two things from us. One, it's the engineering and security expertise of what we build into the platform and what we build into the product, so that they get, for example, on security, they get security built in rather than having to bolt it on after the fact. And so that's really important. But increasingly as well, they want our expertise as an enterprise company that's familiar with dealing with everything from public sector organizations to major corporations to small businesses. We build up a lot of accumulated experience of what's the tips and tricks and patterns and best practices of how to do these things. And it's back to your point about blueprints. And we're increasingly taking all of that knowledge and trying to figure out a way of getting it out of kind of documents in our heads into product and into patterns and into blueprints, so that everybody can benefit from that. And there's quite a lot of feedback loops in our processes to do that. I mean, there's a lot of feedback loop into kind of product features, into open source software, but increasingly as well, I mean, we've done this in some of our security products. It's something we call as part of our Chronicle security analytics engine. We have this kind of community analytics process where customers can choose to join in as part of the community and use us as a platform for sharing knowledge and sharing analytics development, such that they can get the benefit from an ecosystem that's working on things. And in many respects, we increasingly provide that ecosystem.
Great. I want to dig in a little bit on the concept of policy as code. It's become a common buzzword amongst the industry. You know, we believe, and you know, we certainly see in our customers, the target state path to getting beyond compliance as security to actual assurance that you are secure and your controls are achieving their intent. You know, the promise of the cloud and promise of security as code is you can go beyond random sampling. You can go beyond, you know, we inspect it at certain times and actually enforce automated compliance with snippets of code. You know, what we've seen is there's a lot of talent questions in the industry. Somebody who's used to writing a security policy that specifies use hardened images, right? How do you help customers, and what are the struggles and successes you see of security teams trying to translate that to how do I now use, let's say, an example of the Anthos policy engine in Google to restrict the ability to pull non-compliant images into a container? Right, we've seen a big skill set challenge with that thought process. You know, how do you see that evolving with the customers you're working with?
Yeah, so it's worth taking a step back for a second. You know, so the great thing about cloud, and to be fair, cloud-like on-premise capabilities, but generally this is kind of cloud, is that they're a software-defined environment. So this means your configuration can be defined declaratively. In other words, specified in configuration and other related code. And so this kind of brings a couple of things as a result of that were really not possible, or, you know, at best they were kind of very, very hard to do in a more traditional on-premise environment. Is first, you can describe that configuration in code and therefore reason about it. In other words, be able to say, is that configuration describing a secure, compliant, resilient, well-formed, well-architected environment, and does it meet your goals? And then second, the orchestration and provisioning system can take that configuration and create the environment to be exactly like that, nothing more, nothing less. And then exactly to the point you raised in the question, what you can then do is do continuous control monitoring to be able to continuously assure that your environment actually represents that which you specified. And I think, you know, many on the webinar today will probably have some appreciation that most security breaches out there are not a result of like some really new innovative attack that a company has not actually thought of. Most of the time, a security breach is taking advantage of a control that companies thought was there, but turned out not to be there because of some change or some other issue, you know, or they had insufficient defense in depth because they didn't quite understand how their own products were lining up. And so this kind of continuous assurance that your environment corresponds to what you've specified turns out to be not just kind of great for agility and reliability and performance management and kind of cost effectiveness of managing the environment. It turns out to be really crucial from a security perspective. And then again, to the point of your question, when you've got to be able to then demonstrate the compliance of that to get some attestation or pass some audit, in addition to how you're demonstrating its security yourself, you can do that in a much more kind of toil-free, lower cost way. But then all of this configuration as code, which is compliance as code, security as code, resilience as code, ultimately becomes a set of libraries of code you can use to build environments and understand how the security policies should be enforced. And the final thing I'll say is it leads to a whole bunch of other benefits. So the fact that you're deploying an infrastructure according to that configuration leads you down this path of what people describe as being the immutable infrastructure pattern. So in other words, you no longer need to have people inside, fingers on keyboards in consoles of servers diagnosing and reconfiguring environments in production. You basically modify the config, and the config gets pushed as a new deployment, and therefore the result of all of that is people need less privilege. You've got less scope for insider risk and error, less scope for other potential attacks, and so it brings all of those benefits as well. So really, that kind of software-defined environment that you can prescribe how it's configured in a way that's materially different from what you could do in an on-premise environment it's not just transformational for security, it's transformational for how you kind of operate a scale-up, scale-out environment as well.
Whoops, somehow. On that topic, we see a lot of these changes happening with the tech teams on the ground, whether it's a cloud engineering team or a security engineering team, as they evolve to exactly what you described, enforcement of cyber hygiene with automated bits of code, and see the promise of that. How do you see the risk and audit organizations shifting what they do to accommodate? We've seen out in the world with clients where all of this shift happens within the operators of the environment, but the roadblocks around, we still need to inspect, you still need to go to this committee to get approval to deploy your release, which have kind of fallen behind and take away from the value of cloud. How are you seeing some of those risk and audit operating models shift?
Yeah, well, it's interesting. As you probably expect, there's a whole kind of distribution of sophistication here. There's some organizations are at the very beginning of this journey where they're just doing initial cloud deployments, and they've got a very significant on-premise environment, and they've yet to shift to this kind of configuration as code, security as code environment. And then you've got others that are pretty much all have either done their transition or they were always so-called digital native that they built initially in the cloud. And then there's everything in between. I think one of the things that we see, and we work with a lot of audit and compliance teams to help them through this, is they tend to be a little bit behind almost by definition where the security, the DevOps, the SRE, the development and cloud infrastructure teams are. But we're seeing a lot of interest in the audit and compliance functions, because they're starting to realize that their goal is independent assurance that the risk and controls, the risks are being mitigated and that the controls are being enforced. And as they think about more continuous audit assurance and continuous compliance assurance, all of the stuff we talked about before on what you can get from continuous controls assurance in the security team, they can use that to be able to be much more effective at audit and compliance in much more efficient ways to enable them to look at broader risks. And they get to do this again because they can reason about the configuration, and they can get more comfortable that the environment conforms to the configuration, and then they can devote more time to actually thinking about are the risks being correctly identified and are the risks being appropriately mitigated, as opposed to having to just deal with the toil of constantly checking specific controls are being implemented. So again, not only is this security as code, compliance as code, what you get from a software defined environment is not just transformative for business agility and security, it's transformative for like all of the lines of defense, for toil-free or less toil in audit and compliance functions as well. And I think I definitely recommend all audit and compliance teams and embrace this as not just the reality that you have to deal with because this is where the environment's going, but it's a means of 10xing your audit function as well, just because of the basic capability that you now have an ability to look at the environment in different ways.
Yeah, absolutely. And I think what we've seen, right, is that a lot of those departments are caught flat-footed. And I think the more the cloud providers can start to build tools for them to use to figure out how to perform audit, I think the better off everyone will be. I think the business goals we always stumble on are folks want their force multiplier developers to spend their time building engaging experiences for their customers, not filling out audit documentation and responding to audit committee requests. And it's how do you unlock that?
Yeah, no, that's exactly right. Because I just, sorry for going to break it in. I think it's right, because I think a lot of IT providers, cloud providers, build tools for the security team. One of the things that, I think many, including us, have started to build for other teams. So for example, we have this product we built called Risk Manager, which really is just, this is the tool today that customers use to export the information to the cybersecurity insurance companies. But in the future, this could well be the hub for how you export your configuration and attestations to be consumed by auditors, external auditors, regulators, compliance functions. And I think we, as cloud providers, are going to keep investing more and more in providing tooling for all of the constituents of an enterprise risk process, not just the security and IT teams.
Yeah, I completely agree. And I absolutely love that. Before we shift topics for a minute, there's an audience question, which I think is pretty interesting, is, if you've got a board or a CIO who is not quite convinced, right? They're skeptical of cloud. They're not sure that their organization can actually increase the likelihood of a secure and compliant adoption. What's the 30-second, pitch of talking points to the skeptics to get them to think differently, or at least be open to being able to migrate?
Yeah, I mean, look, we often get asked the question of, is cloud more secure than on-premise? And, I wouldn't be so arrogant to just say that's a binary yes, no. As with anything in life, things are a little bit more nuanced, that you could have a very secure cloud that is not particularly well configured by a customer, that can lead to some issues. We've seen issues in the past in various organizations where that's been the case. And similarly, at the other extreme, you could have a hyper secure, locked down on-premise environment, which sometimes you see in very specific use cases. But generally speaking, the economy of scale of the cloud and many other factors really make sure that cloud is becoming more and more secure over time. And there's now, I think, surpassed typical on-premise environments. Like, for example, I can only speak for Google Cloud, but we encrypt everything, all communications. We encrypt our storage. We equip every one of our pieces, server infrastructure that we build ourselves with security chips, our Titan security chips that guarantee a secure boot, do firmware validation, provide a root of trust for the stack that's built on top of that. And that's just, broadly across the environment. Some on-premise environments have those controls, but they typically don't have them pervasive. So most of the time, if you shift to the cloud, you're going to get that security uplift. But we do recognize, and it's back to that shared fate question we started with at the beginning, that we've got to provide more and more help for customers to run securely in the cloud. And to that extent, I kind of think of this as, we focus on defense in depth from attack, but we've also got to keep focusing on defense in depth from configuration errors. And a lot of the stuff we talked about as security as code isn't just about defending against attack, it's defending against leaving yourself open through configuration errors. And this is why we're investing in kind of both of those paths, not just the defense from attacker path.
Great. And that's a great segue to another question dealing with encryption. I think most companies are aware of all the capabilities around encryption that are available in the cloud, but they have trouble thinking through, how do they build that into their applications? If they have PCI or sensitive data needs and need a field level encryption enablement versus tokenization enablement versus block level encryption, how do the CSPs help the clients get to where they need to be, where they can take advantage of all of those offerings by the providers?
Yes, so most of our approach, like with a lot of security aspects of the cloud, is to do as much as we can to build this in so people don't have to bolt it on afterwards. And so we've been investing a lot, as I think a lot of the cloud providers have, in pervasive encryption at the storage and the network level, but also encryption at kind of inter-process communication level, encryption within a lot of the data products, where that's more under customer and application control, plus providing all of the relevant APIs for applications and storage system and database systems to be built using whatever level of encryption is required within the application. And then there's even kind of states now where we have this thing called confidential compute, where you're encrypting all the way up to a secure enclave inside the processor itself, which kind of takes encryption to the next level. Plus, and this is something that's less talked about, the ability for customers to, if they want, and not everybody does, but if they want, to control their own encryption keys. So we have a thing called external key manager, where customers, if they want, can choose to run their own cryptographic key management systems. And we, the cloud provider, have to interact with the customer to release keys to do certain activities. And that's kind of the ultimate degree of control. But the way we kind of see this is it's a set of built-in technologies that can be optionally used without necessarily you having to kind of deploy in after the fact a bunch of encryption technology. And again, this is this thing we like to talk about, is we're forever kind of, raising the baseline of control, because we're reducing the cost of control all the time because of that economy of scale. So people kind of get more option to do more security things in the cloud, because security is more economic to do in the cloud because of the way it's built in. And that's a very transformational dynamic where, to some extent, it's still appropriate to do the classic kind of risk assessment of, is this risk worth the cost of mitigation? But the economy of scale transforms it to the extent that in many cases now you can deploy a set of controls that you don't really need to do the risk assessment, because they're effectively built into the platform. So you may as well just keep them on, whether a particular case needs that degree of protection. It becomes so cost effective, you just deploy the controls everywhere.
Yeah, absolutely. And I want to go back to the assurance and the risk and audit question, because that's generated a few questions from the audience. And then I want to shift to a different topic around, how we start to think about implementation of these things. So these two are really interesting questions. They're really asking about, process and risk and inspection, right? How do you persuade technology executives who, want to have that close oversight of security, and only the security team can review the configuration file, and you must send me your scan report. And if all the reliance is on security as code, right? How do you do true validation? And how do you get these processes to start to loosen up, to accept, to really deliver the business value? We've seen all kinds of cloud transformation failures on delivering business value, and they're usually IT led for the sake and purpose of IT. Right? But if you're truly trying to deliver that lower cost of innovation, faster time to market, right? The tech is only part of the battle. It's those processes around release and approval. And what have you seen work with convincing the folks that own those processes to trust the system, or to inspect the robot if you're assured that the robot is the one doing all of the deployments?
Yeah, well, it's a really timely question, because as more and more organizations adopt this, they're starting to look at their own audit compliance, control self-assessment, control assessment methodologies, and adjust them in light of what we've talked about before. I think the key point here is one of the other great things about security as code is the fact that it's code, right? And you can then manage that just like you would hope to do as part of a well-managed software lifecycle. So you can subject to change management, analysis, testing, the ability to roll back, to do stage deployments. And so in effect, again, you get a number of things from that. So you can apply separation of duties in the change process. You can potentially take more risk in more aggressive policies, because you know you can roll it back if you stumble into an unexpected situation where that security policy might impact reliability or resilience. So like with anything in a more kind of code-driven environment, you can potentially take more operating risk to reduce security risk, because you know you can roll things back. And then similarly, as I mentioned, with the separation of duties, you can have multiple teams making sure they've reviewed their aspect of it before things get released, as well as being supported by all of the automated analysis we talked about before. So the fact that it's code is that gets you to a point where you can put controls around that. The other thing I would say as well is, and this is kind of slightly away from the security as code, but and it comes back to that defense in depth from configuration error, is this is where I think you see, we've done a lot on this, but I think you also see other providers trying to do the same, where you look at the model by which you define your cloud. So we, for example, have a structure where you have an organizational root, and then you have a set of your cloud deployments. And the security team can be given policy control over policies that operate at the entire organization level that can't be overridden by individual IT teams at the deployment level. So that combination of defense in depth and separation of duties about how you systemically implement policy across your entire cloud infrastructure, in addition to how you encode the policy in your configuration code, together they give you substantial defense in depth and separation of duties that really give management the ability to know that the security team is providing a high level of assurance on how the configuration is being sustained. And then finally, again, it's defense in depth. So we and I think the other cloud providers have as well, a number of different controls where you can effectively put what you might call extra service perimeters around an infrastructure. So you have all of the standard application controls, firewalling, segmentation, but then you can layer other surrounding further lines of defense that, just in case there is a configuration error, then you've got a further kind of safety net around your environment. And that, again, is another means of getting people comfortable that they can trust the environment.
Great. Yeah, I think that's absolutely correct. And I want to touch on a few additional topics. I've got a bunch of questions coming in that are really interesting. Back to the security as code and the how, right? And this is something we run into at a lot of our clients as well. The operating model question around who is really responsible for performing, configuring, and programming the security automation, right? Some folks, question, what is the security architecture role versus the enterprise architecture role? Is it a security engineer working with cloud security as a product, or is it the cloud engineers taking security requirements and translating them to code? How do you see, the operating models at the customers that you've been helping start to evolve for success there?
Yeah, well, look, as I think you probably all appreciate, there's no one right answer for this, because the right answer is a function of the nature of a particular environment, the mix of multi-cloud, on-premise, the nature of the business, the nature of the different types of existing systems, all the way through to the kind of the maturity of how the environment's being managed. But we see a number of different things. There'll be some organizations where the development teams basically, get to define their own environment, and then the security team reviews that and identifies issues and fixes it, and then there are other environments where the security team kind of sets up the basic kind of environment with guardrails, and then the development teams get to operate within that. And there's various other models on the whole continuum. But I think where we see most organizations that have got substantial cloud deployments or growing cloud deployments is it really comes down to they have a standard base configuration that prescribes the controls, the defense in depth, and the surrounding control environment for the cloud. And then development teams, through a continuous integration, continuous deployment process, get to deploy to that pre-established environment in the cloud within those guardrails. And then the surrounding kind of security as code approach is how the guardrails and the hard barriers in certain parts of the environment are enforced. And then you see that kind of separation of duties between what the the cloud infrastructure engineering team, the development teams, the networking teams, and the security teams get to work collectively on. But ultimately, it's the security team that prescribes the hard policies as well as the guardrails around how things are enforced. And then there'll be some degree of continuous controls assurance to make sure the environment continues to be configured the way you expect it is. The final thing I'll say is sometimes there is a little bit of a layer of more traditional security activity, like some organizations for various different audit and regulation reasons may still have to do good old-fashioned pervasive vulnerability scanning, even though, and you kind of touched on this before, even though they absolutely know that the container, the artifacts that were deployed inside a signed container are only being executed in the runtime, have gone through the full vulnerability analysis, and you exactly understand what's in there. You then still see some organizations having to do the vulnerability scan, which, again, is a potentially useful kind of check and balance, but it's often not necessary if you've engineered your continuous deployment in the right way, especially if you're using things like runtime, binary authorization, and some other container controls.
And sticking on the operating model topic, we think about teams. Often the largest enterprises with the most aspirational plans are creating completely separate cloud teams so that it's not a side of desk job to create all of the automation and code that's required to unlock the value, and not just move a car that's leaking oil from one parking spot to another, which doesn't deliver a lot of value. But how do security teams who are focused and trained in an on-prem world, right, where it's gates and not guardrails, right, stage gates versus, how do they, how do you try and coach them, and what are keys that they can use to evolve to really unleash the potential of cloud? I think everybody sees the potential in this software environment that I can program and I can automate. But for those that have been operating in a data center with legacy constructs of I inspect things after they're deployed and I know how to think about layer 2 and 3 routing and switching, right? How do they change their thought process to think about cloud to really succeed there?
Yeah, I mean, so fundamentally, the underlying goals remain the same, for the security team, which is to set hard and fast policies and gates and controls that protect the enterprise and protect customers, and then layer within that, if not hard gates, additional some guardrails that kind of guide development teams onto the kind of the right, well-lit security path, but surrounding it all with kind of hard gates to protect the enterprise. And that's still, that job of the security team in partnership with the infrastructure and development and other teams, is still the role and responsibility that carries over to cloud. It's just, to your point, done in a different way. The interesting thing is, we often get questions around how should security teams shift the on-premise mindset to the cloud mindset. And it was funny, I kind of thought about this for quite a while, and then realized that actually, with the cloud, you get to actually implement the right security principles. So if you go back, and sadly, I'm of sufficient age where I remember some of this, you go back to kind of the 70s and 80s when a lot of the first principles of security were defined around least privilege, segmentation, a whole array of other controls that we spent in an on-premise environment struggling to implement, because the on-premise environment and certain types of enterprise software wasn't really compatible with those security principles. Now in the cloud, we get to do least privilege, segmentation, pervasive encryption, default denier, various different things. And so it's much more easy to achieve the principles we as a profession first came up with in the cloud. So the way I kind of think about this now is it's not a case of shifting the on-premise mindset to the cloud. It's about going back to first principles and realizing that what you struggled with in on-premise, you can now do in the cloud. And again, that for me, for many security teams, is a little bit of a light bulb moment that they get to realize I don't have to change my on-premise model to the cloud. I can get to go back to first principles and actually achieve it in a way that is viable because of the very nature of how cloud works. Right?
Yeah, absolutely. That's fantastic insights. And there's a really interesting question about where the puck is going in the future in the chat that I'll get to in a minute. You know, Tony in London, thank you for that one. Before we get there, though, I do want to talk a little bit about, you know, we've talked a lot about prevention and policy as code. And really, you know, I believe that that is one of the absolute keys to success, to being able to achieve the business value, achieve actual speed and velocity and deployment. But we haven't talked a lot about response and recovery, right? How does the concepts of building it right, security as code and automation help in response and recovery? And really, how does that overall complement resilience with infrastructure as code?
Yeah, well, and again, the other good thing about cloud, and you know, and this is generally a benefit, but you know, it can also be, you know, something that's challenging to manage, is the capacity to extract sensory information out of the cloud is just immense. You know, whether it's virtual network flow logs, or like on VM or container logs, application logs, and all the whole kind of spectrum of observability. A cloud environment can throw off a lot of kind of sensory information. Now, of course, you know, the reason I sound guarded on this is, you know, that sounds great, but you've then got to take that into an environment and make sense of that and respond to that. And, you know, and that is a challenge, especially for security teams that have, you know, in many cases grown up starved of data, except for the particular sensors that they deploy. And again, this sounds a little bit self-serving, but, you know, this is again where cloud and the scale of data processing in the cloud applied to the sensory information that comes out of your cloud deployments can actually help. And increasingly, we see some of the best security analytics products are not only the security products, they're actually the large scale data analytics platforms that increasingly as well are coupled with other capabilities like the machine learning functions that we provide and some of the other tooling that we provide. So net, I think, you know, security teams are realizing you can have more sensory ability. The other good thing as well is back to the security as code point, is you are able to then analyze your configuration to then look for places where you've got mismatch between your preventative and your detective controls, or where you've got mismatch between workloads and where you're consuming sensory data. So again, while you could analyze it in deployment, you can also analyze it in your configuration to reason about not just have you got the right protective controls and the right defense in depth from attacks and errors, but have you got the right detective capability as well. The other good thing as well is, and again, this is another kind of additional benefit of a software-defined infrastructure, because you can stand up an infrastructure or a replica or a kind of a cut-down copy of your infrastructure in the cloud. You're able to then do more kind of exercises and tests to test your security team's response to simulated events in a way that you probably couldn't have done by having to physically provision a bunch of infrastructure that was a replica of your on-premise environment. So it lets organizations get a little bit more kind of aggressive in how they can test themselves because of that software-defined nature of the cloud.
Yeah, absolutely. And there's a question that somebody popped in for the second time that I want to touch on briefly, because this is a really interesting one. You know, we talked about blueprints and best practices and secure by default. And, you know, the topical theme is, you know, I don't believe you can be successful with any of that without adopting a security policy as code approach, right? You know, everybody should be thinking about whether I'm taking baby steps, right? That has to be part of the approach, because it's the only way you can scale with the rate of change that the business is going to deliver. You really need the security configurations to move at the speed of business. But we find a lot of folks struggle, and this question, you know, came up here as well. Like, there's a lot of frameworks. There's the NIST framework. There is the Cloud Security Alliance. We've got CIS. We've got all kinds of frameworks around cloud security controls, and they all read like tables of contents, right? Here, you should have all these elements of your program, but they don't contain the specificity. You know, CIS may be a little more than others around what is the best practice, right? So as you're thinking about the blueprints and building services by default, right? What are the standards and that you guys are mapping to, or how are you thinking about what best practices are being codified that can be shared?
Yeah, no, like it is an interesting question, because I recognize the challenge of this. I mean, for many of the more principles and objective based frameworks, as opposed to the frameworks that specify particular controls or control implementations, it's really a case of mapping. And so we do a lot of mapping of our cloud controls and our blueprints to recognized industry accreditation, certification, and other frameworks, and that does become a mapping. And there's not, and sometimes, as I think a lot of people on the on the webinar will know, that it can require a lot of judgment to do that mapping, as opposed to it being like a precise syntactic and semantic translation. It requires some kind of judgment. So it's often hard then to be able to say, do we truly comply with the intent of this framework? Because it's a matter of judgment as to whether you comply with the framework irrespective of a security as code environment. But generally, we're kind of edging up the stack. And you're right, CIS and the CIS benchmarks are much more prescriptive, so they're more amenable to a security as code approach. In a lot of our blueprints, we've taken things like PCI and some other certifications and frameworks and put those in blueprints as code. And we've used our own teams to stand behind the fact that our control encoding in code does meet the intent of the framework, and then we have that independently assessed. So I think ultimately the way I kind of like to think about this is, for an organization, and perhaps in the future, to that point I made before about an ecosystem of sharing these blueprints and configuration as code, is ultimately we end up with a library of configuration, just like you have a library of software that you can assemble and build on each other to deliver that environment. And so if you have a blueprint or security and configuration as code that describes what it takes to be, run a PCI compliant Kubernetes environment, or you have a blueprint that describes the security as code for how to run a high trust conformant data analytic platform. If you ever need to kind of create an application that needs to do them all, you're just kind of taking the libraries of configuration as code and bringing them together into a more all-encompassing approach. So I think that kind of security as code, so that you can manage it as a library and reuse and build on things appropriately, again, is something that I think is going to be transformational to the security, audit, and compliance teams.
I completely agree, Phil. And we have time for one more question, so I'll encapsulate a few into one. And this is about futures and where is it all going, right? There's the future of detection of attacks and malicious activity in the cloud environments, in cloud infrastructure, right? Knowing that there's long latent, there's usually a period where something's happened that's no one's noticed yet, right? Where does the responsibility for developing the future of getting better at that lie? I imagine AI and machine learning play a role, things that Google is, leading a lot of thought leadership at. But how is this going to be applied to creating better secured cloud environments for your customers?
Yeah, I mean, fundamentally, and you kind of hit on this, which is, it's about the research we can apply, and ultimately our goal is, we have this phrase called invisible security. Is, we just want security to be ever present and pervasive and built in, so that you're getting all of the security you need without really having to think too much about it. Now that sounds, for everybody that's kind of worked in security for a long time, that sounds a little bit like a pipe dream, but we're progressively making it happen. And so again, when you think about the examples I gave before about encryption, all the way up through to confidential compute, on processor encryption, a lot of the investments we're making in how identity and access management works, how zero trust in a real production environment works. There's a lot of stuff where the things you used to have to do to create application segmentation, to create the ability to integrate authentication, authorization in APIs, a whole array of things that used to take a lot of effort from your security architecture or security engineering teams, have just been built in as API calls or built in transparently in the product. And this is, we're just at the beginning of this, so there's more and more abstractions to build further up in the stack that get you to this kind of secure by default, security built in approach, where you really shouldn't have to think about this so much. It just should be a part of the platform, and we're going to continue to apply R&D to make that happen, and we're constantly searching for feedback from customers around where the pain points are in the security process, so we can figure out ways of just embedding this in the products and the platform, so it just does, it becomes a lot easier to do. Because again, it's back to that economics contention, is the more we make security easier to do and cheaper to do, the more security we'll have, because there's no reason why the baseline can't keep increasing if we keep reducing the cost of control.
Great, thanks, Phil. I know we're coming to the end of the session, so I'm going to close the questions right now. I want to thank you, Phil. This has been fantastic. Thank you for the time. To all of our participants, we hope you found this engaging and useful, and thank you for your time as well. I think we have, I've got a slide to pull up with my contact information as well as Kate's. For any follow-up, further questions, I know we couldn't get to them all. Feel free to reach out to us directly, and we'll be happy to continue and get questions either with Phil's insights, with ours, but happy to continue the conversation. And thank you, everybody, for participating today.
Thanks.